Assalamualaikum warahmatullahi wabarakatuh. My name is Farhata Adhiya binti Muhammad Fauzi, and I would like to present about mechanical properties of polymers. So, what are polymers? Polymers is a large molecule that made from a long chains of repeating smaller units that we call as a monomer. So basically, the most common shape of the polymers is made in pellets. Which is a small plastic beads. Mostly we use these pellets in industry as a packaging, also automotive, electronics, and also in medical because it's lightweight and durable, and also is easy to shape. So why mechanical properties is matter? Because of course we have to choose the best polymers before we produce our product or design. Next is durability and safety. For example, it's like a medical device that you can use repeated for a daily safely. Yeah. And next is the design efficiency. Of course, we have to understand elasticity and ductility and viscoelasticity before we produce the design. Yeah, to optimize the shapes and also the thickness. And last is of course to avoid high maintenance, to save our money, to save costs. Yeah. So we have a set of mechanical properties of polymers. First one is tensile strength, toughness, impact resistance, elasticity and viscoelasticity, stiffness, hardness, and also creep behavior. So before we go into all of this, we take a look at a graph of stress strain first. So in this graph, stress strain, at this region, elastic deformation, which is that the polymers that can reshape, that can shape its original shape. At this yield point and this yield strength, which the shape begins to permanently alter, that it cannot be reshaped again. And after and that's we call as a region plastic deformation. And after on that, it will break as a fracture point. So first one is a tensile strength. What we call this tensile strength? Tensile strength is a maximum of force that we're pulling before it's breaking. For instance, is the ropes. We use a nylon in the ropes to tie a boat. Yeah. And also in a PET in the bottles, that how much weight that we can support the liquids in the bottles. Second one is the toughness. Toughness is basically how many energy that can absorb before it's breaking. For example, we use a polycarbonate to make a helmet visor and also safety goggles. Because it's a durable, yeah. Next is impact resistant. Impact resistant is ability to absorb the force that suddenly falls. For example, we use polycarbonate and ABS plastic to make a helmet and also a car bumpers because it can absorb any force. Yeah, can have a strong impact. Next is elasticity vs viscoelasticity. What is the difference elasticity and viscoelasticity? Elasticity is materials that can detach and it can stretch or deform under force, that it can revert to its initial force. For example, this is like a rubber and also a pipe. So what is a viscoelastic? Mostly we use in our daily life, such as silicone as our phone case. Viscoelasticity is meaning that they can reform in their shape back, but it takes a time. For example, like a shock absorber and also our cushion mattress, that it can back to its original shape, but it takes time. Next is stiffness. So what is stiffness? Stiffness is like it's like different between a metal and wood. Like metal is very stiff, more than wood. Yeah. For example, we use epoxy for protective covers and panels. Yeah. So hardness. Hardness is the ability of a resistance is to wear or scratch or in a surface deformation. For example, this is a high hardness, high polymer that it can prevent from scratches. For example, we use a polycarbonate and acrylic to make the windows in our lenses. For soft polymer, we use as a bottles and also in a plastic to carry your things. And the last one is creep behavior. In polymers, creep behaviors refers to materials' ability to slowly degrade over time. For example, it's like a rubber door seal scar. They may gradually flatten over time. For like they will flat, but in 1 year and 5 years above. So factors, there are many factors that affecting mechanical properties of polymers. First is like temperature. For example, it's like a plastic spoon. When we put in the hot water, it will bend, right? When we put in the freezer, the spoon will be break easily. This depends of the temperature. So molecular structure is very long, or string chains of polymers is very strong molecular structure. For example, is the polyethylene is more durable, more than branched PE. Next is the degree of crystallinity. The tensile strength and stiffness are higher in more crystalline polymers. For example, in polystyrene is very brittle, but the nylon is very strong and more crystalline. Next is the plasticizers. Chemicals might affect polymers' hardness, toughness, or flexibility. For example, rigid PVC is hard and brittle, where a flexible PVC pipe uses plasticizers. Next is what is the difference thermoplastic and thermoset? Thermoplastic is more flexible and we can remold it and reshape, while thermoset cannot be reshaped. They are robust, very stiff, and heat resistant. So, in conclusion, the polymers mechanical characteristics such as strength, stiffness, toughness, elasticity, viscoelasticity, and creep is very important for engineer to look before we make a product or any construction, because there's to avoid any failure or a cost effective to repair it. Okay, that's all. Thank you.